But after 2017, if you want to register as a team, each team has to have exactly 8 students. Teams don't necessarily have to be from the same high school, but they have to be in the same like defined geographical region. For example, you can't call up your friend from California and form a team with them, right? Uh, and so if you can't get 8 people to be on your team, you can register as an individual. And there are 2 phases to individual applications. There's the general individual registration and the secondary individual registration. And during the general individual registration, individuals cannot apply if they are a part of a school or organization that already has their own application going on. So before you apply as an individual, make sure you know what your school is doing, because if you violate that, um, this may result in the rejection of both your application but also your school's application. So be sure to know what's going on with your school and what's going on with teams before you choose to apply individually. And during the secondary individual registration, only students from schools or organizations whose teams were already rejected can apply, right? Your team has to have been rejected the first time in order for you to apply in the secondary individual registration. And there are fewer people who get in from the second individual registration because at that point they've already selected a group of applications. So however many's left is just however many spots are left. There are 2 divisions in Pumac, Division A and Division B. Division A is obviously more difficult, with the problems ranging from early AME to mid-USA AMO and JMO. Division B ranges generally from mid-AMC to mid-AME, even though sometimes it could be harder. I would say that in terms of competitions, it's harder. It's definitely harder than the November HMMT, but it's a little easier than the February HMMT, I would say. But generally, Pumac is on the harder side of competitions, though I'm not sure what goes on in California, so I don't know how it compares to like SMT and Berkeley and whatnot, but I would say it's pretty difficult. Now, for the individual round, each participant of Pumac will take 2 individual tests from a choice of 4: algebra, combinatorics, geometry, and number theory. The individual tests will have 8 problems in the subject areas chosen by the participants. Each individual test is 1 hour. And if you do well on the individual test, I believe the top 10 from each division and each category will be chosen to take the individual finals. And the individual finals is a 90-minute proof-based test of 3 problems, and you do it, and that counts towards your individual ranking at the end. The team test happens after the individual tests, and collaboration is allowed and encouraged. Each team will be given a set of instructions and problems, and they must do their best to finish the exam within the time limit, which varies year to year. And I think what's interesting about the team test is that its scoring is pretty interesting in the sense that um, different questions have different weightages. So you can develop a sort of strategy when you go about taking the team test. Um, the website described it as sort of like a game, and you can strategize and use game theory and whatnot to figure out what you want to solve, which questions you want to solve first, etc. And there's also the live round, which is another test that you take with your team. But the reason why it's called the live round is that the rankings and the scores are being updated live. So you know where you are while you're doing the test, which makes it more chaotic and fun generally. Okay, so now we get to the power round, and there are technically 2 Pumac competitions. There is the power only competition, and there is the main competition that you take at Princeton. If for some reason, whether it's logistics or apply or something, and you're not able to make it for the main competition, then you can choose to take the power only competition instead. And you can only take one or the other. You can't take the power only competition and the main competition. Now, the power round it consists of proof-based questions that are larger in scope than normal competition math problems. And the concepts that you need for the power round are definitely a lot more advanced than what you would need for normal competition math. The power round will be made available online for teams a week before the competition date. So you will have a week to work with your team of 8 people to solve the power round. And unless otherwise specified, you can't use textbooks, the internet, your parents, whatever. But I mean, technically they wouldn't be able to know, but it is prohibited. And also, so the power round, you can either submit it to them via email, or if you're taking the main competition, you can submit it in person the morning of the competition. And it's a 1 day competition, by the way. You get there at around, like, you register at around 8, and then you can get out of there at around 4:30. So this is the scoring. So for teams, the overall team rankings will be based upon their performance in Power Individual Live and team tests. For individuals, each of the 2 individual tests will contribute 25% of a participant's overall individual score, and individual finals will contribute 50%. Ties will be broken by difficulty of problem solved in the individual finals or elegance of proofs. In the end, at around like 4:30 usually, the award ceremony will acknowledge the top 10 team performances on the power round, team test, and overall team standings. They also announce and post rankings of the top 10 individual performances for each individual test subject and the top overall individual performances. Okay, and here are just some stuff that occurs so often on the test that you should definitely take extra time to study. In terms of algebra, polynomials is a huge thing. You'll always see it, and there will be a lot of questions on polynomials, functional equations, inequalities, complex numbers, and sometimes limits. Trigonometry is also pretty common. It appears in both the algebra and geometry sections of the individual test. It would help you a lot to know trigonometric identities. And for geometry, it would be helpful to know law of sine and cosine, and also Euler's identity, and just be able to go from, complex numbers to trigonometric functions and back and forth. And also for the power round, it will definitely help you if you learn more advanced things that you aren't taught in high school and don't appear in normal high school competition math. For example, vector spaces, set theory, ring theory, matrices. Oh, and another thing, even though there's 2 divisions for Division A and Division B, the power round is the same for both. So Division B, despite the in-person competition being generally easier, it will still serve you well if you studied a bit of advanced math. Okay. So how do I recommend you study, right? It's not all that different from how you would study for like normal competition math problems. And I'm sure that you guys have your own routine going on and what materials you like to study. But it will definitely be helpful if you look at past Pumac test questions. You can find all of it online in the archives. And as per usual, AOPS books are always helpful. And even though the style of questions are not identical for Amy and like the Amy and USAMO, JMO questions are not identical in style to Pumac, but I would say they're roughly of the same difficulty. So it would be helpful to do some practice on Amy and USA JMO problems. I also find that Evan Chen's Otis excerpts are pretty helpful when it comes to studying for especially higher level competition math. And if you want to have an introduction to abstract algebra without having to read a long textbook, um, University of California, Berkeley has posted this 83-page PDF called Introduction to Abstract Algebra Math 113. You can find it online. And I think it's a pretty good intro to abstract algebra before you get to the power round. And if you're good at Chinese and you can read Chinese, I recommend the book 近世代数基础. You can also find this online. It's a pirated PDF online. So if you're able to read Chinese, um, that could also be a book that you use to study abstract algebra. Okay, are there any questions so far? No? Okay, great. Um, so that was just kind of the gist of the competition, the format, what happens. And now we'll just look at a few problems that that came up in previous years, so you can get a taste of what Pumac problems are like. Okay, this is a sample problem from, I believe, a Division A algebra individual test. So I guess I'll give you guys some time to look at it on your own, and then I'll go over the solution. I would say that usually it's just high school students taking it, like 9 to 12. And because there's an application process that you have to submit a form to them, if if you're under ninth grade, they might not take you because you haven't done enough math. Like, that's what they think. Somebody has asked to see the first few slides about the individual round. So before we go over this one, I guess I'll just talk a bit about this again. So you take 2 of 4 tests from these four branches of math. And if you do well, if you're top 10 in your division, in your category, then you get to take the individual finals. And during the finals, it's a proof-based test that lasts for 90 minutes, and you have 3 problems to solve. Division A gets slightly harder problems than Division B. Does that answer your question? iPhone. All right, well, I guess it did. Um, no, you do not take both A and B. When you register, you either register for Division A or Division B, depending on how well you think you do. Okay, so now let's go over the algebra sample question. So the question was asking for the number of real solutions to the system Now, it's not difficult to see that the first equation will be a parabola because sine x squared minus y equals 0 if and only if x squared minus y equals k pi for some like k in the integers, right? So this will just be, y equals x squared minus k pi for some k. So this will be a parabola. Now, the second equation, it's not hard to see that when you graph it, it will be a square. It will be like this. Sorry, it's a bit ugly, but it will be a square with the intercepts being 2 pi and negative 2 pi. Now, essentially what this question is asking for is the number of intersections between the parabola and the square. So we just essentially look at the values of k. It's clear that when k is less than or equal to -3, there won't be any intersections, right? Because then it doesn't match. So then there will be 0 intersections for k less than or equal to 3. And there will be 1 intersection for k equals sorry, when k equals -2, there will be 1 intersection. And if the vertex of the parabola is within the square, then like if it looks something like this, right? Then there will be 2 intersections. So when k equals, when k equals -1, 1, or 0, then there will be two intersections. When k equals 2, there will be 5 intersections because it will be like wait, wait, no, sorry. Um, if the vertex of the parabola right, never mind. There sh there should be 5 intersections, and then for if k is greater or equals to 13, then there'll also be no intersections because then x equals greater than 2 pi. So then there'll be 0 for these. And then for 3 less than or equal to k, well, k less than or greater or equal to 3 less than or equal to 12, it will look something like that, which will give us 4 intersections. So then you add all of them together, you get 1 plus 2 times 3 because there are 3 values for which there are 2 plus 10 times 4 because there are 10 values for which there are 4, and then 5, and you get 52 total intersections. So there are 52 real solutions to this system. All right, so now this is a combinatorics problem, I believe from a division B. Actually, no, this is the first problem to a division A. Okay, so that wasn't a very difficult combinatorics problem. It's generally the type of thing that you would expect to see within like the first three Amy problems, I'd say. All right. Now, so the question was asking, the alien Connor starts at 0, 0 and walks around on an integer lattice. And he takes one step of length 1 in a uniformly random cardinal direction every minute, unless his previous 4 steps were all in the same direction, in which case he randomly picks a new direction to step in. Every time he takes a step, he leaves toxic air on the lattice point he just left, and the toxic cloud remains there for 150 seconds. After taking 5 steps in total, the probability that he has not encountered his own toxic waste is A over B. And as per Amy style, they want you to find A plus B. Right. So we know that the only way he can actually encounter his toxic waste is if he goes like from right to left, I mean left to right, for example, and then goes immediately back, right? Because if he takes 2 steps, then there's no way for him to go back to the place where there's toxic waste. Since the toxic waste lasts for 150 seconds, which is 2.5 minutes. So then he has to re-encounter his toxic waste within 2 steps. So now, okay, now we can actually solve it. So suppose that his first 4 steps were all made in the same direction, right? Which that happens with probability 1/4 cubed because the random it's uniformly distributed. Um, and the probability that he doesn't step into his own toxic waste at the end will be 2/3, right? Because after he goes after he goes 4 steps in the same direction, he has to choose one of the other 3 directions. And the probability that he chooses the one back is 1/3. So the probability that he doesn't is 2/3. Um, right. So then that's the probability of this. And otherwise, if he is not going in the same direction for 4 steps, that would be a probability of the fourth cubed minus 1/4 cubed, right? And we solve this and we would get right, the probability that he makes 4 steps without all going in the same direction and without encountering his own toxic waste would be this. And based off of this, the probability that his last step, his 5th step, also avoids his own toxic waste will be 3/4, right? Because now he has 4 directions to choose from and he just has to not go back. So then, well, that would be the probability of him not hitting his toxic waste after 5 steps by not going the same direction. So then we have this expression as our total probability. And we solve it. And we get that A plus B equals 505. And that's just what a number 1 combinatorics problem would look like for division A. All right, and I believe this geometry problem is a number 1 for division B. So give you guys a bit of time to look at that. Okay, so that also was not a particularly difficult geometry problem, but keep in mind that this is just the first one and it gets more difficult from here. Okay. So we're told that triangle ABCD has AB equals 24 and BC equals 7. And we're trying to find D squared, where D is the distance between the the centers of the incircles of ABC and CDA. Now, obviously, because it's a rectangle, we know that the two triangles are congruent, right? Um, and if we use the pretty well-known identity that the area equals RS, where, well, A is the area and R is the in radius and S is the semi-perimeter, we solve and we get, so A equals 1/2 times 7 times 24, and S equals 7 plus 24 plus 25 over 2. So this equals 84. And this is 28. Yeah, 28. So then we get that R equals 3. And because they're congruent, we get that the in radius of both, sorry, that was an ugly B. We get that the in radius of both of these triangles, both of these triangles are 3. Um, just pretend that's a straight line. Like estimate around here, right? So then we know that the horizontal distance between the two would be 24 minus 3 equals 18, right? Because this distance is 3, this distance is 3. And then the vertical distance would be 7 minus 3 equals 1. So then d squared equals 18 squared plus 1 squared equals 325. Okay, and now we have a number theory problem. This this was in a division A, and it was one of the early ones, maybe like 2 or 3. This one's a bit more difficult and it requires some more calculations, but essentially what you do is that for a good number, you just write it as like n minus 1 squared plus n squared plus n plus 1 squared. You expand it, you get 3n squared plus 2. For an excellent number, you write it as like I guess m minus 1 squared plus m squared plus m plus 1 squared plus m plus 2 squared, and you expand that, which I think ends up being 2m plus 1 squared plus 5. And then essentially, so a good number is excellent if it's a bit hard to explain, but essentially you expand it out and then you do some rearranging and then you look for factor pairs and in the end you'll get it. Okay, so for power round questions, this is what they generally look like. But before in the whole power round document that you'll be getting, it's a pretty long PDF, and they actually give you a lot of the context that you need for this. For example, if you look at this is the whole document, and here at the start it tells you what you can and cannot do and when it's due and whatnot. Oh, well, that's an interesting date. But anyways, oh, this is because this is 2022, so the dates were a little messed up. But it gives you this pretty long document and it gives you a lot of the context that you need for these problems because some of the people might not be familiar with ring theory before starting it. But even with this context, I still advise you to know how ring theory works and set theory and stuff like that. Because if this is the first time you're seeing these definitions, it's going to be harder for you to come up with a solution than someone who's already familiar, right? Like here it defines what a ring is and then its properties. And here it asks, and then it asks questions like these, which are essentially immediately based off of the stuff that you just saw. And looking at hmm, looking at number 1 of 1.1.1, if you know ring theory, then it's pretty obvious why the set of even numbers is not a ring. You can prove this using proof by contradiction, by assuming that it is. And if we assume that the set of even numbers is a ring, then there must be, by the definitions that they give us above, there must be a multiplicative identity. Now, we assume that if we assume that a multiplicative identity exists for the set of even numbers, then we can let that identity be E, right? That is usually a notation. So because it's the multiplicative identity 2E equals 2, and this requires that E equals 1, but because 1 is not an even integer, it's not in the set of even integers, meaning that the set of even integers is not a ring based off of these conditions. And those are just the sort of proofs that you'll have to do throughout this whole document. And that's what the first problem to a power round looks like. Are there any questions? And after I guess you guys have tried out some of the problems in Pumac to see if it's for you or not, you can decide this year if you want to attend or not. Oh, okay. Uh, Yeah, so for Pumac, there are two divisions. There's Division A, Division B. Division A is harder with early AME to mid USA, AMO, JMO. And for Division B, it's mid AMC to mid AME. And you can only take one at a time. When you register for one or the other. Are there any other questions or clarifications? Well, if not, I guess that's all I have about Pumac. You're welcome. Good night.